If you have a passion to solve problems of mechanics and forces, then this video is for you. Good evening, friends. This is Manas Patnaik, your friend and tutor. And in today's video, we wish to drive this nail out from a wooden block. By the way, you guys can pause the video and go through this description. Let me give you a complete explanation of what has been asked in the problem. Here we go. So there is this wooden block inside which we have got a nail, and what we wish to do is we need to pull this nail out. Okay, and to do that we need to apply a horizontal force. But as you can see, there is some object over here. That is, there is some kind of an obstruction which prevents us to apply this horizontal force. So what we've done is we have arranged two ropes, one along this direction while the other along this direction. In this direction we have applied some force P. At what angle we are not sure about it. We'll work it out, don't worry. Secondly, we have applied a force of 4.2 kilonewton over here at a certain angle theta, and by the way, theta can be calculated using this perpendicular and this space. Tan theta can be applied to find this value. Okay, what we need to do is that we need to find the minimum value of P, and secondly we also need to work out how much this X is. Okay, this is going to help us find the width of this total obstruction. So far so good. What to do? Let's proceed. Here we go. Just take a look at this arrangement. Take a look at this theta. Can we apply trigonometry? Yes sir, we can. Tan theta will be equal to 125 divided by 200. Take a look. 125 over 200. Do it. Theta will be equal to 32 degrees. 32 degrees. Let me make the update over here. Done. Okay. We have assumed that this angle P makes a certain angle alpha with the horizontal or with the resultant. Okay, the resultant has to be horizontal. Okay, because the nail is horizontal, and in order to drive it out, you have to apply a horizontal force. So far, so good. Now what? What we'll do is, around this resultant, we are going to make a parallelogram. So we are going to make two sides. One side will be parallel to this side. The other side will be parallel to this side. You can do it manually. I have done it perfectly like this. Let me show this to you once again like this. Right? Take a look. Since we are going to be applying the law of sines for triangles, that is why I have made a parallelogram. Okay, a parallelogram is basically made up of two triangles, you can say. So far so good. If you watch, if this is alpha plus 32, then this also has to be alpha plus 32. Okay, how? Just think about it. This line and this line, aren't these two lines parallel? Yes sir, it is parallel. Now take a look at this. What about this line, green colored line that you see? What do you call these two lines? Sir, we call this a transversal, and hence if this angle is alpha, this has also got to be alpha. If this angle is 32, this also has got to be 32, and hence I have made this change. Now I want all of you to focus just on this triangle. Okay, let me just highlight this. I want all of you to focus on this portion of the triangle. You can focus on the bottom triangle also, no issues. So what you can do is, in order to, you have these two angles, alpha and 32. In order to calculate this angle over here, we can subtract alpha and 32. And what you have is basically 180 minus 32 will be equal to 148 minus alpha. So this is your new value. Done. Let me do this. So far so good. Now, if this side is P, this side of the triangle is going to be 4.2. If this is P, this also is P. If you don't believe me, what I'll do is I'll shift this arrow over to this side, and now you believe me? Yes, it is. Okay. I want all of you to focus on this upper triangle like this. Take a look. What we'll now do is that we'll apply the rule of sines for a triangle, for any triangle in fact. Just focus on this force P. Okay, sir. What is the angle in front of this side P? The angle in front is 32. So P divided by sine of 32. Done. Secondly, focus on this side of the triangle, that is R. The angle in front is 148 minus alpha. Therefore, R upon sine of 148 minus alpha. And finally, you have this side 4.2 kilonewtons. The angle in front is alpha. And hence, you can write it like this. Okay. Now what? We are interested in calculating the minimum value for P. From this equation, we will have two expressions for P. One in terms of R and alpha, and other in terms of just alpha. Here it is. I've written it down. Now, we are going to play with both the expressions, starting with this one. What do we need? Sir, we need the minimum value of P. If you want the minimum value of P, then this denominator has to be maximum. Okay. So, which trigonometric function are we interested in? Sir, it is sine. When do we get the maximum value of sine? If, say, this is sine x, and let's say this is x, when do we get the maximum value of sine x? Sir, it's very simple. If we make the plot, it is something like this for one cycle. This happens to be 0. This is where we get the maximum value, that is at 90 degrees. And here the value obtained is positive 1. Therefore, this value 148 minus alpha must be equal to 90 degrees. And from here you can calculate alpha, which is equal to 58 degrees. Done. Okay. I did not start with this expression because making this denominator maximum makes absolutely no sense. Okay. For this to be minimum, this has to be maximum. Makes no sense. Anyway, so you don't worry about this. You start with this expression. Now you have got the value of alpha as 58. This 58 value has to be plugged in over here to get the value or minimum value of P. Let us do it. The value which we've obtained is equal to 2.62 kilonewtons. Everything is in kilonewtons. Okay, so far so good. Now, what we'll do is, we've got the value of P. We also know at what angle we need to apply P. What we now need to do is we need to find this value of x. And in order to do that, we are going to simply apply trigonometry. Tan 58 is equal to x divided by 200. Done. And x is equal to 320 millimeters. Now let me make an update to this figure. Here it is. So we've got all the answers. We know the value of P. We know the value of alpha. We know the value of x. In fact, you can sum these two and you can see that the total width of the obstruction is equal to 3 plus 1 is 4, 2 to 4, 445 millimeters. Okay, 8 minutes and 21, 22, 23 seconds. So guys, that was all from my side for today. And if you've got any doubt or query, write them down in the comment section below. And if you find this content enriching, give this video a like and share it with as many friends as you can. And also subscribe to my channel. This is Manas Patnaik signing off. Take care and have a nice day. Thank you for watching.